everybody, and welcome to an explanation of types of learning with respect to how a machine learns. So, types of machine learning. And the first is supervised learning. Supervised learning. Here, you could actually see it as, let me explain before I write it. So, supervised learning is a type of learning where we train the model with labeled data. So, let's say, for example, this is our data set. So, this is an image of a dog, and then an image of a cat. To help the model understand what a cat is or how a cat looks like and how a dog looks like, we label each of them. This is a dog, and then we say this is a cat. So basically this is a labeled data. So this is in the context of if we want to train a model on how to classify images. So we label each of our data points. Data point is one subset of the entire data. So one point of the data, we label it. If it's a cat, cat. If it's a dog, dog. If it's a penguin, penguin, and all like that, we label it. That's a labeled data. So we feed this labeled data into the model, and the model learns the data by mapping the input. The input will be the image, and the output will be the labeled dog. So it learns the relationship between the image and what makes it a dog. So that's what labeled data is. So let me just write it: label. Labeled data. And examples of this are, and write this with another color. Let's say examples, image recognition or image classification. Speech recognition. Okay, so let's go to the next. We have loads and lots of examples. Of course, it's more than two, but I'm just restricting it to two to help you understand the context. So to revise and recap again, supervised learning is a type of learning where we train our model with labeled data. And labeled data is a data or data set that has input and output. So the input is the image of the dog in this context using image classification. The image and the output is dog. So we fit it in with the image, and we teach it that once you see an animal that has these features, it is a dog or it is a cat, and so on and so forth. And in context of speech recognition, especially for transcription, let me even put that into especially transcription or transcribing. So imagine exactly as I'm talking like this. So it's recorded like this, and then somebody or a human being annotates it, that is, transcribes what I'm saying, my spoken words, into written context. So that's a labeled data. So the machine or the model is fed with the audio of me speaking with my spoken word. That's the input, and it's also fed with the answer. So see, there's a question and answer. The answer is the written or transcribed words. So the next time when you fit it with the spoken words, it knows how to write it in written context. So C, label data as question and answer. The question is the image or the spoken words as the context may be, and the answer is the transcribed words or the tag or the label. So let's go to the next type of learning, which is unsupervised learning. So, unsupervised learning, on the other hand, is where or involves training the model with unlabeled data. So, as I put it, unlabeled. So you can imagine, how does an unlabeled data look like? So let's just try to visualize it. So imagine this is our data set, and all of these are data points in our data set. So because they are not labeled, here our model is tasked with the responsibility of learning patterns in the data set on its own. Since it doesn't have the spies like this, doesn't have the input and output, doesn't have the question and answer, input and output, it has to learn the data on its own, try to understand it, and try to extract any statistical references it can. So that's the unsupervised learning. And examples of this, a very popular example of unsupervised learning is, you might have heard of it, examples is, I'm just going, clustering, anomaly detection, and to mention a few, there are loads and loads of examples of it. So let me explain. So clustering, for example, maybe this is a data set of a store's daily sales or weekly sales of customers, or maybe for the year 2024, this is their data of all the sales they've made. So we could just input this data set into our model and tell it to cluster based on customer behavior similarities. So it just clusters based on customer similarities. And for example, it could say this set of customers buy on a weekly basis, or this other set of customers spend this so amount, or this set of customers buy this certain kind of product, and so on and so forth. And anomaly detection, you could even use it in cybersecurity protection, where the model, based on the data you give it, it's able to say this kind of behavior is an anomaly. It's not what is common within the data set. So you could use unsupervised learning for that. And basically, generally, unsupervised learning is for unlabeled data. That's data that does not have labels or tags on them. So let's go to the next one. And the next one is semi-supervised learning. So this type of learning is actually a very tricky and an interesting one, because it combines both or it leverages the strengths of both supervised and unsupervised learning. It uses both labeled and unlabeled data. So let me put that here. Both labeled and unlabeled data. How do I mean? Okay, so let me try to give a visual representation of this. So this is our labeled data. For example, dog, cat, and then let me draw the cat, the dog. Okay. Apologies for the drawings of the cat and dog still. Okay, so now this is how, or the kind of data a semi-supervised learning model uses. This is labeled. Try it. And this is unlabeled. So this is labeled. So basically, this is used especially in context where labeled data is scarce, or it's gonna be really capital intensive, both human wise and money wise, to obtain the labeled data. So the model is first trained on labeled data, on the small or limited amount of labeled data. Then, so see the labeled data training as the foundation and the first step of training. Afterwards is now trained on the larger amount of data, which is then the unlabeled data. So an example of this is, so the examples would help drive the point home. Speech rare, cog, me. Speech recognition. So first of is trained on labeled or annotated data. So as I'm speaking, the spoken words of mine would be transcribed by human beings into written text. And this will be done for hundreds or thousands of other spoken words. So now the model is given this transcribed spoken word into written text, trained on it, so that it understands the meaning of specific words and phrases and how they're used. And then it is given the larger amount of unlabeled speeches, which is spoken words, for it to decipher on its own, to continue training on its own after it has gotten the proper foundation of being trained with labeled data. So it gets the foundation, the strength, the understanding of what words and phrases mean from the labeled or annotated data. And then the larger data set, which is the unlabeled data in this case, helps it to understand nuances in speeches, understand context, understand accents, let it explore on its own and be able to get or gather or connect the dots the way a machine knows how to do best. So semi-supervised learning leverages the strengths of both labeled and unlabeled data. I hope I was able to explain that better. Another example is medical imaging. Medical imaging still follows the explanation of speech recognition, but this case, you first of all give it labeled data, the limited amount of labeled data, where the images of scans and biopsies and all of those stuff are labeled so that the computer or the model has a foundation on how to interpret the unlabeled data. Okay, so to the last and not the least, we have reinforcement learning. Okay, so do the reinforcement learning. Okay, so this reinforcement learning is kind of fun to me because I see it as a gamification. So let me explain it before I go into write it. So reinforcement learning, how we train the model. We train the model to make decisions in an environment. So we simulate an environment where we train the model to make decisions by rewarding or punishing it. Let me explain. So see the environment as this. And look at our AI agent here. So if it goes this way, we reward it. If it goes this way, we punish it. So let me even reward punish it or penalties. So we train our model to make decisions by rewarding or punishing, which the Reddit call it penalties. So if our AI agent goes this way, and it's not meant to go that way, we what? We punish it by giving it a penalty. And if it goes this way and it's meant to go that way, we reward it. So that's how it is. What are the examples of reinforcement learning? First is autonomous vehicles. This is how autonomous vehicles are trained based on reinforcement learning. If it goes left when it's meant to go right, it's punished. If it doesn't stop when it's meant to stop, that's when it sees maybe a passerby and it's meant to press the brake and it doesn't, it's punished. If it does, it's rewarded so that it improves itself by heading more towards actions that would lead it to be rewarded. Another example is game playing agents, such as chess and AlphaGo, if you've heard of Go. the game go. So this is how those AI models or agents are trained. When they make the right move, they're rewarded, and when they make the wrong move, they are punished. And that's the end. Let me know if you have any questions, and see you till next week. Bye-bye.